Now, welcome to the module pertaining to the fault tree analysis. Now, this related to the quantitative risk analysis related to the fault tree. So, let us have a look about that what we had studied in the previous module. We had gone through the basic concept of event tree. We have gone through the definitions and different steps of guidelines related to the event tree. We have discussed about the protocol related to the event tree development, how we can develop the event tree. We have gone through the advantage and disadvantage related to the event tree analysis, discussed about the various applications, and above all we have gone through the and we had a discussion about the difference between the qualitative and quantitative risk analysis. Now, in this particular module, we are going to have an introduction of fault tree analysis, how it originated. We will discuss about the understanding of the model of this fault tree. We will go through the basic definition, history, and we will discuss about why we need to perform this fault tree analysis. Now, once we will discuss this basic aspect of fault tree perform, then we will discuss about the basic building blocks of fault tree analysis and how we can perform this fault tree analysis. So, once we will develop and discuss all these things, then we will discuss about the advantages and disadvantages associated with the fault tree analysis with application. So, let us have an introduction of this fault tree analysis. These industrial operating system, they consist of a combination of various components. They are clubbed together to form a single unit to perform a specific operation. Now, let us have an example like the production of ammonia. Here it is quite simple that we are having the nitrogen reacting with hydrogen to give you ammonia. But there are several other steps involved, there are several other components involved. The basic component is that what is the appropriate temperature, what are the safety methodology. Now, if now obviously this reaction is an exothermic reaction, then how to control the exothermicity of that particular reaction. So, there are various components involved in the production of this ammonia. So, these components are clubbed together and they form a particular unit for the production of ammonia. So, once we are having the different units, so it is desirable to analyze the possible failure sequences, those who are related to such operations, and we need to perform a probabilistic analysis while developing a production cycle to successfully mitigate any kind of risk therefore associated with that particular thing. So, we need to carry out a failure analysis with these 6 words like where, when it happened, why, who was involved, how it happened and what. So, based on this type of sequential questions, you may perform these kind of studies. Now, this is usually a preventive analysis, and this analysis is performed to protect the end user from unidentified and unacceptable consequences. So, the fault tree analysis is you can say the one of many tools available to identify the potential failures and mechanism associated with them. So, it is a hierarchical representation of various events, those are directly or indirectly interact with each other. So, you are having different events in a particular plant. So, they may be either interactive or maybe non-interactive with each other. So, to produce other events, sometimes if by the interaction and non-interaction, they may produce other events and develops a way through which a particular failure can occur. So, hence a proper functioning of system must be known before performing any kind of fault tree analysis. So, as fault tree produces a separate hierarchy for each event, it becomes invaluable for analyzing big and complex processes. It is a very important point. Now, let us discuss about the origin of this one. Now, as product and process technology becomes more and more complex, that we have already discussed with respect to one example of the production of ammonia, the visual fault tree analysis approaches has been proven to be invaluable as a standalone risk technique or supplement to the failure mode and effect analysis. Now here you are having FMEA, that is the failure mode and effect analysis. You may start with any one of the function that detect the various failure mode, go for the severity, then you go for the probability, go for detection, and then you perform the risk priority numbers, that is R, represented with the multiplication of severity, probability and detection. So this is termed as the failure mode and effect analysis. Now let us have an understanding of the model that the fault tree analysis is a top-down deductive analysis technique which is used to depict the possible consequence or the possible sequence of any event failure. So it provides all the possible path through which a particular failure event can occur in the single hierarchical chart. This FTA is constructed by the help of Boolean logic, through which each step is divided into two extreme outcomes, whether it is true or false. Now these events are arranged in a sequences of a series relationship through ORs or the parallel relationships through A and D or AND of the Boolean logic. Now these sequences they lead to form a tree like a diagram formed through the logical symbols which visualize the dependencies among the events. Now the event can be, you can say, the mechanical component or a software glitch, or can be arise from the electronics used while designing the system. So the failure event of any particular system under the study is called the top event, this one. Now the event which cannot be subdivided further in different branch or subsystems, so hence is the terminating group of the branch of the tree, that is called the basic event. Another definition, that is the fault. What is the fault? This is an abnormal undesirable state of a system which can be attributed to the implementation of wrong command, or sometimes with no implementation of command, or due to failure of system or component of the system. So if the system is interrupted by a safety device and has been shut down, then it will not be counted as a fault, because this is a deliberated event. Now failure, that is the loss of functioning of a system or component of the system, that is called the failure. For example, let us say if the pressure vessel burst, the vessel failure. The cooling coil is not functioning due to the corrosion, sometimes leaking, sometimes lack of pressure, etc. So sometimes the cooling system fails. Now sometimes it may happen that thermocouple coil is broken, hence the relief device is unable to detect the system temperature. So it may be termed as a relief device failure. Now there is different failures. One is the primary failure. Now if the failure is occurred due to the system itself, like failure within the lifespan, leakage, the system has no exposure to the surrounding, then it is called the primary failure. Now the secondary failure, the failure occurred due to the exposure of the system to the surrounding or manufacturing errors, such as sometimes improper design may lead to such kind of failure, wrong selection, either maybe in terms of raw material, maybe in terms of process conditions, like with respect to the pressure and temperature. Sometimes there may be certain operational errors, such as the use of device above the rated limit, etc. So these are termed as the secondary failure. Then there is a concept of multiple occurring event, that is called MOE. So MOE, or a failure event mode that occurs more than one place in the fault tree. This is also known as redundant or repeated event. Another is the multiple occurring branch, that is referred as MOB. Now this multiple occurring branch is a branch that is used in more than one place in fault tree analysis. So all basic event in multiple occurring branch will be the multiple occurring events in that particular case. So, branch usually a subsection of a tree. The module an independent subtree or branch that contains no outside multiple occurring event or multiple occurring branch and is not a MOB, that is the multiple occurring branch. There are certain cut set limits or cut sets. These terms like cut set, this is a set of events starting from basic event to the undesirable top event that together cause the top event to occur, that is called the cut set. One is the minimum cut set, that is sometimes referred as MCS. Now, this is a cut set with a minimum number of events that can still cause the top event. There is a superset. This is a cut set that contains a minimum cut set plus additional event to cause the top undesirable event. The critical path, this is the highest possibility cut set that drives the top undesirable event probability. Other is the cut set order, the number of elements in a cut set. The cut set truncation, this is the removal of cut set from consideration during the fault tree evaluation process. These cut sets are truncated when they exceed a specified order or a probability. So, let us have a look about the history of this fault tree analysis. So, this fault tree analysis was first developed in 1961 for the United States Air Force by H.A. Watson at Bell Telephone Laboratory for the use of with the Minuteman system. Now, later it was adopted extensively applied by the Boeing company. So, that is why we have used the trademark of these two, Bell Telephone Laboratory and the Boeing. So, the system safety analysis tool, which was developed in 1963, and this applied to the entire Minuteman system for safety in between 1964 to 67 and 1968 to 1999. The first technical paper presented for at the first system safety conference held in Seattle, June 1965. Then it was used by Boeing for the design and evaluation of the commercial aircraft, and in the year 1966. The Boeing developed the 12-phase fault tree analysis simulating program in the Colocomp plotter, and further it was adopted by nuclear power industries in between 1971 to 1980. One of the many symbolic logic analytical technique found in the operation research discipline. So, the recognized software codes, they are included with the prep kit, sets, FTAP, the importance and COMCAN. They are adopted by the chemical industries in between 1981 to 1990. The commercial code developed that works on various personal computers, it was in the 1991 to 1999, and it was adopted by the robotics and software industry simultaneously. Now, the fault tree analysis is best applied to the cases with which are having the large and perceived threats of losses, that is, for example, very high risk. Some cases there are the numerous potential contributors to a mishap. Sometimes a complex or multi-element systems or processes, they may have the fault tree analysis. Sometimes already identified undesirable events, this can be applied. Sometimes certain indiscriminable mishap causes like autopsies, etc. So, in that particular case we may apply this fault tree analysis. This provides a traceable logical quantitative representation of causes, consequences and event combinations. These are the amenable to, but for the comprehensive system requiring use of softwares, etc. There is no intuitive requires training, not particularly useful when the temporal aspect they are important. Now the question arises, why fault tree analysis? Why we are looking for this fault tree analysis? The basic purpose of this fault tree analysis is to identify the combination of equipment failure and human error that can result in an accident event. So a predictive mode. Now the question arises, okay, we know that why we are using this fault tree analysis, but when to use this fault tree? So there are a couple of options. One is under the design mode, that is the fault tree analysis can be used in the design phase of the plant to uncover the hidden failure mode that result from combination of equipment failure. Another is with respect to the operation. So this fault tree analysis including operator and a procedure characteristic that can be used to study an operating plant to identify the potential combination of failure for specific accidents. Now let us have a look about the results. There are various types of results. Now a listing of sets of equipment or operator failure that can result in the specific accident. So one mode is this one. Now these sets can be qualitatively ranked by the importance. The nature of result, that is the qualitative with the quantitative potential. This fault tree can be evaluated quantitatively when probabilistic data are available. So this is the foremost requirement, that you must have all these data with you. The other requirements, this may includes the staff requirement. So under the staff requirement, one analyst should be responsible for a single fault tree. So with frequent consultation with the engineers, operators and other persons who have experience with the system or any kind of equipment, those who involve that particular equipment involved in the process, that are included in the analysis. The next is a team approach is always desirable if multiple fault trees are needed. So with each team member concentrating on one individual fault tree. There must be interaction between the team members and other experienced person. This is always necessary for completeness of this analysis process. The data requirement. A complete understanding how the plant system functions, that is the utmost requirement for this system. The knowledge of the plant system equipment failure mode and their effect on the plant or system, it is quite essential under the head of the data requirement. The time and the cost requirements, they are highly dependent on the complexity of the system involved. Modeling a small process unit could require a day or less with an experienced team. The large problem with the many potential accidents or accident event and the complex system could require several weeks even with an experienced analysis team. So that is in terms of a variable. Now while considering the applying the fault tree analysis, you must postulate the top event, that is the fault, then branch down the listing fault in the system that must occur for the top event to occur. Must consider the sequential and a parallel or combination of the fault. Use Boolean algebra to quantify the fault tree with the event probabilities. You need to determine the probability of the top event, that is once you have postulated the top event, that is fault. Then adopt for the fault tree logic. Now use this logic gate to show how a top event occurs. Higher gates are outputs from the lower gate in the tree. The top event is output of all the input fault or events that occur. Now there are certain, let us have a discussion about the fault tree building blocks. So you can divide into the 4 different groups: basic event, gate event, conditional event or the transfer event. So let us have a look about the basic event. that is the failure event, that is the primary failure, or usually denoted by the circle symbol. The secondary failure, that is represented by the diamond symbol. The next is the normal event, and usually it is denoted by the house symbol. This is an event that describes a normally expected system state. Now, the probability can be either 0, that is no, or 1, that is yes. So, these are the various symbols which are being used in the fault tree analysis. This is the circle, the basic and primary event, the conditional event, the undeveloped event, the external house event, the dormant event, the basic primary event. Now, these events they are represented by the legends. They are an event. This one represents the event. This one is the basic and a primary event. This one is the conditional event. This is the underdeveloped event, and this is the house or external event. Now, let us have a look about the gate event. This is the logic operator combining the input nodes. So, a gate event is a junction where a fault logic is either permitted or inhibited. So, there are only two options. Now, there are 5 basic type of gate events: AND gate, OR gate, NOT gate, priority AND gate, and exclusive OR gate. Now, there are certain condition events. So, it develops a condition that is required for the occurrence of the gate event. So, these two are interlinked. Now, these conditions are symbolically attached to the gate event. Now, there are 3 type of condition event: inhibit, priority AND, exclusive OR. There are transfer event. This is a pointer used to a tree branch like this. Now, it indicates a subtree branch that is used elsewhere in the tree, and it is represented by a triangle symbol. Now, it can be used for several purposes. Now, it may start a new page of plot. It indicates where a branch is used numerous places in the same tree, but is not repeatedly drawn, that is the internal transfer. Now, it indicates an input module from a separate analysis, that is called the external transfer. So, these are the gates, gate and other symbol: AND gate, OR, NOT, that is the priority one, exclusive OR. This is the combination, this is the inhibit, and this is the majority vote gate, that is M input out of N input, N output. Now, this is the sequence gate, and these are the transfer symbols. This is the transfer in and this is the transfer out. Now, let us have a look about the union. Now, here there are 2 events, either B or C. So, if this switch is open, then definitely there would be no current, and if the battery is at 0 volt, then definitely there would be no current. So, A is the result of B plus C, and B or C must occur for any kind of event that needs to occur with respect to A. Now, whereas in intersection, you are having the 2 system E and F. These are simultaneously, they need to be occur, like this is the 5 milliampere current in the system, and a power applied should be greater than 1 millisecond. So, these 2 needs to be occur. So, E and F must occur for any kind of this process to be happen. So, there are guidelines for the developing fault tree analysis. You must replace an abstract event by a less abstract event. Classify an event into the more elementary events. You need to identify the distinct causes for an event, and the couple trigger event with no protective action. You need to find the cooperative causes for an event and pinpoint a component failure event. So, these are the certain guidelines for the development of a fault tree. Now, question arises, how to perform the fault tree analysis? There are 5 basic steps to perform the fault tree analysis. These are: you need to identify the hazards, you need to obtain the understanding of the system which you need to analyze. Then you create a fault tree, then based on your knowledge, you identify the cut sets. So once you identify the cut sets, then you try to attempt to mitigate the risk whatever being identified through this particular analysis. So let us take the first step, that is defining the undesired event, and that is obviously is having the top event. So usually several different but equivalent fault trees can be constructed for a given system. So also different top events, they led to the different fault trees. So it should be defined that as precisely as possible. So you need to ask or frame several questions, that how much impact does the top event pose to the system? What will be the duration of that particular top event? What are the consequences of happening, that is the safety impact? What is the environmental impact? What is the regulatory impact? So you need to frame all these questions and you need to answer all these questions. Then identify all the immediate, necessary and sufficient events to the top event. Now those immediate events, they are the collection of past event, previous experience, they should be always included in fault tree. The necessary event, always try to include only those events which are actually necessary. Now inclusion of a small faults event lead to the complication and complicated visualization of the scenario. There are sufficient event, so usually do not include more than the minimum necessary. Now the second step is to obtain the understanding of the system. This create or acquire the appropriate support information. This includes the list of a component involved in the system, boundary diagrams, schematic diagrams, code requirement, that is safety code associated to the system, engineering noises and environments, example of similar product or failures, and in case if you have any previous fault tree analysis data, it should be included. Then starting from the top event, list the potential causes of hazard in accordance with the level, that is the top level, level 1, 2, 3 to the basic event. The development of fault tree should be focused on completion of single level first and then proceed to the next level. So always try to include the past experience in the design engineers who have good physical, thermodynamic or chemical engineering knowledge of that particular system. Now this knowledge is very crucial for cause selection. Now it is usually a teamwork, this process, hence assigned a skilled person to who can assist in developing the relationship of the cause to a failure or fault. Now the procedure is continued until the basic failures are identified. So identify each causing event as one of the following path, like primary fault, secondary fault, command fault, etc. Then you need to estimate the probability of the cause at the base level event. Now label all causes with quotes and prioritize or sequence cause in order of occurrence or probability. Now the next step is the construction of a fault tree. The set of events that all required to produce an event of interest are connected to an AND gate. Then the set of events that can individually produce an event of interest are connected to OR gate. It is a complete analysis of system including mechanical, software as well as the electronics used in the system. Now these risks may be prevented through engineering choices or control through quality control. Now the basic event depicted usually as a circle or oval. Now the basic event is the point at which the team can address the risk. Now usually typically they are color coded, usually red, that is the critical risk, orange, that is the high risk, yellow, you may have a minor risk, and a green, that is acceptable or a very low risk. The fourth step is to identify the cut sets. Now, risk is estimated for each event. So, when available, the failure rate data can be used to calculate the risk of a single chain or many chain. Now, if there is no data, an estimate is established based on subjective guidelines similar to those used in FMEA development, failure mode analysis. Now, the cut set with the risk greater than the system can tolerate, that is the safety or inoperative conditions are selected for mitigation. So, the actions are required for the critical, that is the red one, and the high risk, which we have already discussed with respect to the orange color. Now, the minimal cut set theory says that the fault tree consists of many level of basic and intermediate events linked together by AND or gates. Some basic events may appear in different places of the fault tree. The minimal cut set analysis provides a new fault tree logical equivalent to the original with an OR gate beneath to the top event whose inputs sometimes in the bottom are minimal cut sets. Now, each minimal cut set is an AND gate with a set of basic event input necessary and sufficient to cause the top event. Then we will have a performance correction and the make decisions. So, application of Boolean algebra and minimal cut set theory will result in identifying the basic events that is A and the combination event B, C, D that have the major influence on the top events. So, this will give the clear insight on what needs to be attended and where the resources has to be put for the problem solving. The last step, that is the step 5, that is the control of hazard identified. Now, have you plan of action according to the fault tree analysis? Now, any risk that is not corrected up to the desired limit can have the potency for the system failure and hence can be treated as a topic of mistake proofing and quality control. Now, controlling such issues, they may lead towards the satisfaction and protection of customer from the risk. The examples of mitigation strategies. So, when a risk is unacceptable, for the team may have several options available. There are a few examples of the options available, like you may have an option to change the design, you may have a selection of a component with higher reliability to replace the base level event component. Now, this is often expensive unless identified early in product development. Then the physical redundancy of the component. Now, this option usually places the redundant component in parallel to the other one. So, both must fail simultaneously for hazard to be experienced, and that is very unprecedented. So, if a safety issue exists, the option may require non-identical components. Then the software redundancy, the addition of sensing circuit which can change the state of the product often reduces the severity of the event by protecting component through duty cycle changes and reducing input stresses when identified. There are certain warning systems. So, the circuit may just warn of an event. Now, this requires action by an operator or analyst. So, it is important to note that if this course of action is taken, the human factor, reliability, they must also enter into evaluation. So, this particular aspect is important. Another one is the quality control. So, this may include the removal of a potential failure through testing or inspection. Now, the inspection effectiveness must match the level of severity that the hazard may impose on the consumer. There are certain things you need to remember while performing the fault tree analysis, like always try to omit inputs with small probabilities. Always remember the difference between the active and passive components. Sometimes you may need to ask yourself, does the quantified tree make sense? Don't fault tree everything, be careful with the Boolean expressions. You must have a independent versus dependent failure modes. Ensure the top event is having the high priority. Now, the fault tree quantification, this analysis is not quantitative analysis, but can be quantified. So, the question arises how to quantify this one. So, draw fault tree and derive the Boolean equations, generate the probability estimates, assign estimates to event, and then combine the probabilities to determine the top event. So, this is the usual protocol for this quantification. Now, let us have a look about the advantages of fault tree analysis. This searches for the possible causes of an end effect which may not have been foreseen. The cut sets derived in fault tree analysis can give enormous insight into various ways the top event occurs. It is a very useful tool for focused analysis, where analysis is required for one or two major outcomes. The graphical representation of fault tree analysis help understanding the logic. The starting from top event, convenient selection of the point of interest to find the root cause of the problem. The monitoring and control optimization of the safety performance of a complex system is usually possible under the head of this fault tree analysis. Now, easy compatibility towards the system safety and towards the reliability of the system. Now, it deals well with the parallel, redundant or alternative fault paths. Usually, it provides the framework for thorough qualitative and quantitative analysis of the system. The cut set method can be developed to give the enormous insight into various ways unwanted top event may occur. Now, creating the list of precarious equipment part or a various event, the result can directly rank the contributors leading to the top event. Now, one may use the mathematical model. A number of modes could be arrived at: repairable one, non-repairable one, or standby modes. So, there could be consideration of sensitivity of cases for modification to system component, architecture and component testing intervals. So, we have discussed a lot of with the advantage of this fault tree analysis. Let us have a look about the limitation of fault tree analysis. They require a separate fault tree for each top event and makes it difficult to analyze the complex system. Now, the fault trees, they are developed by the different individual, they are usually different because they depend on their own perception. So, they are usually different in structure, producing different cut set limits and results. So, the same event may appear in different parts of the trees, leading to some initial confusion. So, this is the disadvantage of this fault tree analysis. Apart from this, it is very time consuming analysis and requires a large efforts for a complex system. Sometimes the possibility of omissions may occur, then the failure event probability may increase. There is no existence of any kind of partial failure, and sometimes it is an integral part of a process. For calculating the error, probability of top event, probability of all basic events are necessary, which are not always possible to obtain because it may lead to a cumbersome process. So, this is again one of the disadvantage of fault tree analysis. Let us have a look about the application of fault tree analysis. They are used in the field of safety engineering and reliability engineering to determine the probability of safety accident or a particular system level failure. Now, they are used to monitor the performance of the system. They are used to assist in designing a system as per the safety and regulatory concern. Sometimes they are used to analyze the effect of medication in the present system. They are used as a diagnostic tool to identify and correct causes of the top event. They are used to understand the impact of changing environment or change in the duty cycle of the same design. So, in this particular module, we have discussed about the various aspects of fault tree analysis, different guidelines limitations, advantages of the fault tree analysis, how do we construct this fault tree, and we had a small discussion about the application of the fault tree analysis. For further studies, you may have a look of the references listed in this particular slide. Thank you very much.